I've been teaching an Introduction to Programming class at Baylor College of Medicine for the past 15 years or so, and I finally decided I might as well go ahead and make the lectures generally available for anyone who wanted to watch them and learn a little bit of programming. While I do normally teach this class to graduate students at Baylor College of Medicine, this was really targeted at people who had never learned any programming before, people who are in, say, biology and never taken any programming classes or anything like that. So later in the series of lectures, we might get into some stuff that's somewhat science-specific, but most of the lectures are really just going to be focused on learning how to program from ground zero. So it should be pretty accessible for just about anyone that wants to watch them. Just start out with some general background about programming and programming languages, that sort of thing. Programming exists at a lot of different levels, and it's been around since the first computers, obviously. Computer languages range from low-level languages, where you're sort of fundamentally telling the processor in the computer exactly what to do step by step, to sort of high-level languages, which work at a level of abstraction and just lets you use more advanced concepts in designing your programs. So this course is going to be taught using a language known as Python, which was first developed in the early 1990s. Python actually predates the development of Java, and it's one of the higher level languages that's out there. Just to point out that there are lots of computer programming languages in existence. There are 8,512, the last time I looked it up, known computer languages, which have been cataloged. Now, only a small handful of those computer languages are really actively used, sort of similar to the spoken human languages. There are 6,909 known human languages, many of which are defunct and no longer really spoken by anyone, but quite a lot of them actually still are. Anyway, there's only really a handful of languages which are really used on kind of a regular basis by a large number of programmers. So Python has recently risen to be sort of the top of the stack of popularity as far as programming languages go, and there are some solid reasons why this is the case. If you looked at this 15 years ago, where I was still teaching this course in Python, Python was sort of way down the list, but it was very good for the sorts of things that I was targeting the audience. But now Python has become pretty popular for a wide range of different purposes. Python was originally developed by this guy Guido van Rossum, and it's named after Monty Python, not after the snake. So you will find, if you read through the Python documentation, lots of references to Monty Python. So if you see anything funny in the Python documentation, it's quite intentional, and you'll need to know your Monty Python to figure out exactly why it's talking about what it's talking about. So Python is known widely as an easy-to-learn programming language. It's used very widely. One of the reasons it's used so widely is because it has so many available libraries. What are libraries? Well, libraries are sets of routines which have been written by someone for other people to use. So there'll be a set of routines designed for some specific purpose. So you may have a big library of routines for doing certain types of math, or you have a library of things to go out to airline websites and find the best airline price. So you can find libraries for doing a wide range of different things, and there's a nice searchable set of libraries online where you can find things that already exist, and this can save you a lot of effort when you're trying to write your own programs, because a lot of the code that you need may already be written for you. It's a fairly powerful, high-level scripting language, as I mentioned before, and it also can provide scripting for third-party software. So what do I mean by that? Here's just a short list of a few software packages which use Python or can use Python for internal scripting. What that means is, for example, we take GIMP. GIMP is basically a free Photoshop-like program. It's open source, been around for a very long time, and one of the scripting languages that GIMP supports is Python. So if you know some Python programming, you could do things like automate tasks inside GIMP. So if you wanted to say, take a picture and do certain brightness contrast adjustments to it automatically, or maybe align it to other pictures, or any sorts of things that you might want to do routinely in an image processing sort of app, you can develop a little Python script to do it and make your life a lot easier. So if you don't know any programming, you can use all of these programs. If you do know some programming, you can get more out of them. I will point out that I will be giving these lectures about Python 3, version 3 of the Python language, as opposed to version 2 of the Python language. Python actually comes with a lot of different computer operating systems. It comes on Macintoshes. It's built in. Any Linux installation that you might make, it's built in. But the version you'll often find installed by default is Python 2 still, whereas Python 3 has been the current standard for almost the last 10 years. And it's not completely backwards compatible, so you should make sure that you're using Python 3 rather than Python 2 if you're trying to follow along in this class. For the class that I teach at Baylor, we use a package called Anaconda. It's a larger distribution which includes Python as one of its components, and it also includes a bunch of other things. It basically saves you a lot of effort. If you install Anaconda, it installs Python, and it installs a whole bunch of other libraries that go along with Python and a bunch of other tools, nice and easy to use, and it's completely free for individuals to download and install. If you want to use it commercially, then they have some licenses that are available, but for individual users, you can download it in as many places as you want and just use it. And it's got lots of nice documentation, that sort of thing as well. So I highly recommend, if you want to learn how to program in Python, this is a great way to start out. The other aspect of this is just a list of some of the packages which are included in Anaconda. What we'll be using for these lectures is Jupyter Notebooks, and more specifically within an environment called Jupyter Lab. And this gives a nice sort of interactive web browser-based interface to Python, where you can type commands and have them stored and display the results, save the results, that sort of thing, and work with it very conveniently. There are a bunch of other software packages out there which have similar sorts of notebook structures, things like MATLAB and Mathematica. The packages like that have a similar sort of structure. If you don't know what those are, don't worry about it. It's not a big deal. Anyway, so we'll be working with Jupyter Notebook, and we'll introduce how to use Jupyter Notebook in the first module, which will be the next thing that we get into. Now, the first few modules, I've sort of chopped all of the lectures down into these bite-sized 15 to 30-minute pieces. The first few modules may be a little on the boring side. It'll give you something to do right away. You'll be able to use Python as a calculator, and you'll be able to manipulate text and strings and stuff like that pretty quickly. But they're not super exciting sorts of libraries. It takes a little time to learn how to program. So bear with the first few lectures, and hopefully once you get into the fourth or fifth module, you'll begin to be doing some more interesting things with Python programming.